Hello and welcome back to the screencast. Hopefully, a clearer sounding screencast playing with some new equipment today. Hi, everybody, it's Mr. S. We're talking about math you should know, and today we're going to be talking about representing functions using words and equations. Essentially, we're going to be reading some word problems and writing our own algebraic equations. For example, a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. And we can write an equation that says the distance, or d, equals 8t. And kind of reviewing and going back, we've been working on an art project where we are doing x's and y's. We are, in this case, saying t. I got the t from there, and that should equal d. And I guess our equation would be 8 times t will equal d. So if I, say go 1 hour, 1 times 8 would be, 8 miles. If I run for 2, I will run 16 miles, and then in which case I will then have to run to the hospital because that's an enormous distance to run. Take a look at a word problem and give it a equation. The Drama Club is holding a bake sale. They are charging $5 for each pie. You know what? Before I move any further, I'm going to circle that number. That's a constant that I'm probably going to have to use in our equation. Write an equation to find the total amount earned, T. So I'm looking for the total amount for selling P pies. So I have one constant, two variables, and the word problem literally tells me I'm trying to find T. He's going to go over there. That stands for T, the total amount of money I'm going to make. I'm going to say, well, there's a 5. I'm going to multiply that times P, 5P. So let's just see if we can make sense out of this. If I buy 1 pie, the total cost would be $5. Makes sense so far? 2 pies would be $10. These are cheap pies, by the way. And if I bought 10 pies, that would be $50, which still is a pretty good bargain for 10 pies. That's how you do this type of problem. Let's move forward. We also talked about graphing. As long as the machine lets me go forward, here we go. And the graphing, there we go, it looks like this. We've been doing this with our art project, by the way, due tomorrow. Taking a table, even though this says H and ML, this really is X and Y. And we plotted over here on this graph these coordinate pairs. This sounds very familiar. We've done this. I see 0, 0. I see 1, 8. Over 1 up 8. And over 2 up 16. And those of you that have been really paying close attention to what we've been doing in algebra knows that this is a linear equation because it's a straight line on this graph. One more example, and then I'll cut you loose. This isn't about the one I want. That's a good one. There you go. Oh, good. Student Council is holding a car wash to raise money. They're charging $7 for each car they wash. Graph the ordered pairs. Analyze the graph. Well, let's take a look at, first of all, what a formula might be to solve this. And I could say, well, X and Y, and knowing that my X's are the number of cars washed. And so let's just pretend we're going to wash 1 car, 2 cars, and 3 cars. And for each car that I wash, I get $7. So I think 7x equals y would be a fantastic formula. And let's make some ordered pairs. By the way, the y is the total of dollars earned. 1 times 7 is 7. If I do 2 cars, I'll have $14. If I do 3, I'll have 21. And then I'll stop because I'm tired. Let's graph it. And 1 over and up 7 should be right about there. Right about there we go. 2 and 14, right about there. and 3 and 21, right about there. And if I would line those up and take a straight edge, say this ruler, which you can't see in screencast land, look how nice and straight that is. It makes a nice straight line because that's a linear equation. Ladies and gentlemen, that's what we're doing tonight. We're changing word problems into algebraic expressions, algebraic equations. Ladies and gentlemen, thanks for watching. That's the maths you should know.